Looking at the map right now, what we're seeing across North America is a weather pattern that's organized into three main active zones. This isn't a single unified storm system covering the entire continent. Instead, we have distinct areas of weather activity, each producing different types of precipitation in different regions. Understanding which zone affects you is the key to knowing what to expect over the next day or two. So let's break this down zone by zone and talk about what's happening. The three primary active zones are, first, a broad northern snow belt stretching from southern Canada into the northern United States. Second, a precipitation shield across the eastern United States, particularly focused on the Appalachian region and the mid-Atlantic. And third, localized precipitation cores around the Rockies, especially near Colorado. Between these active zones, much of the central and southern United States remains relatively quiet. So this is a divided pattern, and your experience is going to depend entirely on where you're located. Let's start with the northern snow zone, because this is the most widespread feature on the map right now. When we look at the precipitation layer, snowflake indicators are clearly visible across a massive area. This snow zone extends from western Canada through the prairie provinces, across southern Ontario and Quebec, and then down into the northern tier of the United States. This isn't scattered, isolated snow showers. This is a broad snow coverage associated with a large cold air mass that has settled in across the northern part of the continent. In the United States, the areas most at risk for snow are along the northern tier, particularly in the northern Rockies, the northern plains, and north of the Great Lakes. If you're near the Canadian border, especially in areas adjacent to the Great Lakes on the northern side, you're in the heart of this snow regime. The cold air is firmly entrenched, and any moisture that moves through this region is going to fall as snow. This is the kind of setup where snow can be persistent, rather than just a quick passing shower. It can fall steadily for hours, and accumulation adds up. The reason this snow zone is so extensive is because of the temperature structure. When we look at the temperature map, we see blue and purple tones across Canada and the northern United States. That's cold air, well below freezing. This cold air mass is what's supporting the widespread snow. As long as that cold air stays locked in place, which it appears it will for at least the next couple of days, snow remains the story for the northern tier. Now let's shift to the eastern United States, because this is where we have a completely different type of weather happening. Across the Appalachian region and the mid-Atlantic, particularly focused on West Virginia and Virginia, we have a precipitation shield that's bringing rain, and in some areas, thunderstorm activity. The map shows precipitation indicators with lightning strikes, and that tells us this isn't just light, steady rain. There are convective elements embedded within this system. Let me give you some specifics based on what the map is showing. We're seeing accumulation values across various cities in this region. Charleston is around 0.9 inches. Roanoke is around 1.1 inches. Richmond is around 0.7 inches. Elizabeth City is showing 1.3 inches. Columbus, Ohio is around 0.2 inches. Knoxville is around 0.4 inches. Evansville is around 0.3 inches. Raleigh is around 0.4 inches. Charlotte is around 0.3 inches. Clarksburg is around 0.3 inches. And Bristol is around 0.2 inches. What these numbers tell us is that we have a persistent rain shield across the region, but it's not uniform. Some areas are seeing heavier rainfall than others. The higher accumulation values, particularly in places like Elizabeth City and Roanoke, suggest that certain areas are getting hit harder. And when we combine that with the lightning indicators, it becomes clear that there are thunderstorm cores embedded within the broader rain shield. These thunderstorm cores can produce brief periods of much more intense rainfall. So if you're in West Virginia, or nearby areas, and you see a thunderstorm move through, don't be surprised if rain rates suddenly spike and conditions deteriorate quickly. The mountainous terrain of the Appalachians adds another layer of complexity to this situation. When you have persistent rainfall over mountainous areas, water runs off quickly. Streams and creeks can rise rapidly. Valleys can experience flash flooding. If you're in eastern West Virginia, western Virginia, or the mountainous parts of North Carolina, be especially aware of this risk. Don't camp near streams, don't drive through standing water, and if you're in a flood-prone area and you're told to evacuate, take it seriously. The convective activity, those thunderstorms we talked about, can also produce localized heavy rainfall in short periods. Even if the broader system isn't causing widespread flooding, a thunderstorm that sits over one location for 30 or 40 minutes can dump enough rain to cause localized flash flooding. This is particularly true in urban areas where drainage systems can become overwhelmed, and in steep terrain where water has nowhere to go but down. Now, there's also precipitation showing up over the Atlantic Ocean, just offshore from the east coast. This is moisture streaming in from the ocean and feeding into the system. If this offshore component shifts closer to land, coastal areas of the Carolinas could see rainfall intensify. Right now, it looks like the heaviest action is staying just offshore, but coastal areas, particularly in North Carolina, are seeing some of that moisture. Elizabeth City's accumulation of 1.3 inches suggests that coastal areas are indeed getting impacted by this Atlantic moisture feed. Let's move west and talk about the Rockies and the area around Colorado, because there's a third zone of active weather happening there. The precipitation map shows a stronger core of precipitation positioned around Colorado. This isn't as widespread as the northern snow zone or the eastern rain shield, but it's a localized area of more intense precipitation. The colors on the map, showing greens and yellows, indicate heavier precipitation rates in this core. The key factor here is elevation. Colorado is mountainous terrain. At lower elevations, in the valleys and the Front Range cities, this precipitation might fall as rain or a rain-snow mix. But as you go higher in elevation, it's going to be all snow. The mountains of Colorado, southern Wyoming, northern New Mexico, and even western Kansas on the fringes could all see impacts from this system. For mountain passes, this means potentially hazardous travel conditions. Snow accumulates quickly at high elevations. Visibility drops. Roads become slick. If you're planning to travel through the Colorado Rockies or any of the mountain passes in the region, check conditions before you go and be prepared for winter driving. Temperature is the underlying factor that's controlling all of this. So let's talk about the temperature map in more detail. What we're seeing is a very clear north-south contrast. Across Canada and the northern United States, we have blue and purple tones indicating cold air. Across the southern United States and the Gulf Coast, we have yellow and orange tones indicating warmer air. This temperature gradient is what's determining precipitation type across the continent. In the northern snow zone, temperatures are well below freezing, so any precipitation falls as snow. That's straightforward. In the eastern precipitation shield across West Virginia and Virginia, temperatures are milder, so precipitation falls as rain. But there's a transition zone, and that's where things get tricky. Along the southern edge of the Great Lakes, across parts of the Midwest, and along the Appalachian Ridge, temperatures can be marginal. In these areas, precipitation type can vary. You might see rain at lower elevations and snow at higher elevations. Or you might see rain transition to snow as colder air moves in. This transition zone is always the most challenging to forecast, because small changes in temperature can lead to big changes in what type of precipitation you see. The satellite imagery backs up what we're seeing on the precipitation maps. Cloud coverage across the central United States shows a banded frontal structure. This tells us we have a frontal system moving through the region. Around the Great Lakes, there's extensive cloud cover, which is consistent with the cold air mass and snow potential. And along the East Coast, over the ocean, we can see a separate cloud and precipitation structure. This offshore component is that Atlantic moisture we talked about earlier. So the satellite is confirming what the other maps are showing us. We have multiple active zones, each with its own weather story. Let me summarize this region by region so it's clear what's happening where. In the west, particularly in the Rockies and around Colorado, we have localized precipitation, with snow likely in the mountains and rain or mixed precipitation in the valleys. The strongest core is positioned around Colorado, and mountain passes could see hazardous conditions. In the north, we have a broad snow belt extending from southern Canada into the northern United States. This snow zone is persistent and widespread. If you're in the northern plains, north of the Great Lakes, or near the Canadian border, you're dealing with snow. The cold air is locked in, and it's not going anywhere quickly. In the east, particularly across the Appalachian region and the Mid-Atlantic, we have a rain shield with embedded thunderstorms. West Virginia and Virginia are in the heart of this system. Lightning indicates convective activity, which means localized heavy rainfall is possible. Coastal North Carolina is also seeing impacts from Atlantic moisture. Accumulation values vary across the region, with some areas seeing over an inch of rain. In the central and southern United States, conditions are relatively quiet. The main active weather is in the three zones we just discussed. The south is warm, so snow is not a factor there. The central plains are between the active zones, so impacts are minimal. Let's briefly touch on Canada and Mexico, because they're part of the continental picture. In Canada, the snow coverage is extensive. This is the source region for the cold air that's affecting the northern United States. Southern Canada is seeing widespread snow, and that cold air is feeding southward across the border. Canada is essentially providing the cold air foundation for the northern snow zone in the US. In Mexico, the weather is relatively calm. Mexico is outside the main active zones. The role Mexico is playing in this pattern is maintaining the warm air mass over the southern United States. That warm air is what's creating the sharp temperature contrast we see on the map, and that contrast is what's driving some of the weather dynamics. Now let's talk about risks and what you need to be aware of depending on where you are. If you're in West Virginia, or nearby areas in the eastern precipitation shield, the main risks are persistent rain and localized heavy rainfall from thunderstorms. Flash flooding is possible, especially in mountainous terrain and near streams. Urban flooding is also a concern in areas with poor drainage. Monitor radar closely. If you see heavy rain approaching, be prepared for conditions to deteriorate quickly. And if you're in a flood-prone area, have a plan. If you're in the northern snow zone, the main risks are snow accumulation and reduced visibility. Roads are going to be slick. Travel will be hazardous. Give yourself extra time if you have to be on the roads. Make sure your vehicle is prepared for winter weather. And if you're in an area prone to lake effect snow, be aware that localized heavy bands can set up quickly and produce intense snowfall rates. If you're in the Rockies or around Colorado, mountain travel is the main concern. Snow at higher elevations can make mountain passes dangerous or even impassable. Check road conditions before traveling. Carry emergency supplies in your vehicle, and be prepared for conditions to change rapidly. Weather in the mountains can shift from clear to snowing heavily in a short period. The bottom line is this: North America is dealing with a divided weather pattern right now. We have three main active zones. The northern snowbelt is broad and persistent, supported by deep cold air. The eastern precipitation shield is bringing rain and thunderstorms to the Appalachian region and the mid-Atlantic, and the Rockies have localized precipitation with mountain snow. Each zone has its own weather story and its own risks. The central and southern United States are relatively quiet, sitting between the active zones. This pattern is going to persist for at least another day or two, so if you're in an affected area, stay informed, monitor conditions, and be prepared for the specific hazards in your region. This is a classic divided pattern, where different parts of the continent are experiencing very different weather at the same time.